Hello, the Jamb 41's channel members, subscribers, and viewers. It's my pleasure to welcome you to the Jamb 41's channel. In this lesson, we are going to give attention to mathematics. We shall be looking at this topic, variation. Variation is one among the 9 topics in mathematics, in science, that of course Jamb 41 considers to be very important in preparing any scholar to understanding the concept of mathematics and of course science at large. And don't forget, like I've always maintained, mathematics is one such subject that helps in brain development faster. You can agree with that. So in this topic, variation, we are going to take one among the 4 subtopics in variation. I'll be giving attention to direct variation. And please, dear friends, it's important for you to know that this topic is one such wonderful topic, as it cuts across all levels of education, as it cuts across all other aspects of sciences. Of course, you're going to find out as we move on. When you talk about scientific laws, most of them are modeled in line with one among the 4 types of variation. Okay, so as always, I encourage you to give rapt attention to this lesson as we look at direct variation. If you're yet to subscribe to this wonderful channel, please kindly do so. Hit the subscription button, turn on the notification bell, so that once I upload any new content, you will be personally notified. Don't forget to share our videos to your friends, your classmates, your schoolmates, okay? Invite them to subscribe also, so as to follow us as we guide you in your studies. You're preparing for Waec, for Jamb, or any other professional exam, Jamb 41 is a channel to always follow up with. Let's be your educational plug. Alright, let's get to the focus of this lesson. We are talking about variation. What is variation? Now, one first thing that will come to our mind is maybe thinking of the English term variation. And of course, that is indeed great. Here we look at changes. When you talk about variation, you are looking at something that can change. So in mathematics, variation is an expression that relates changes in 2 or more quantities. You can see the definition showing on the screen. So when I give you one quantity, I give you another one, okay, let's say 2 in this case. If one of them is changing, how does it affect the other one? Alright, what studies it is variation. Remember, the quantities can also be more than 2. Is that okay? Depending on the type of variation that you are studying. Alright, now that you've known what variation is, we are going to give attention to types of variation. When studying variation, there are 4 types of it that you want to give attention to in mathematics. One of it is direct variation. The second is inverse variation, also known as indirect variation. Number 3 type is joint variation. Then the 4th one is partial variation. These are the 4 types of variation that as a student you need to get yourself used to. This lesson is going to focus on direct variation. So without wasting time, let's move straight to direct variation. But please, don't forget that variation is also known as proportion. Step by step, we are going to treat these 4 types of variation from Jamb 41 here. Make sure you follow up. Direct variation is that type of variation that relates 2 quantities in such a way that as one of the quantity increases, the other also increases. I hope that makes sense, right? As one of the quantity increases, the other also does what? Increases. Which means there is a direct relationship here. Are you following, right? What happens to one of the quantity is the same thing that happens to the other quantity. Well, it's important to also know that as one of the quantity decreases, the other quantity is also expected to decrease. The point is, what happens to one quantity is what will also happen to the other quantity. And the proportion is uniform. Are you following, right? Let us assume that, okay, quantity A increases by 3, then quantity B, if it is directly proportional or varies directly as quantity A, that quantity B will also increase by 3. If quantity A is decreasing, let's say by 5, quantity B will also decrease by 5. In real life, we have several examples of direct variation. Think about this. Let us assume that you are traveling from one state to another state. Okay, just simply you are moving from one point to another point. Are you following, right? And then maybe you have to fill your car, all right, with petrol. Am I communicating? So let us assume you are traveling from point A to point B, okay, to point B. And then you are also traveling from point A to, let's say, point C, okay. You would notice that the distance from A to B and the distance from A to C, they are not equal. Are you getting me right? They are not equal. You will agree with me that if you are moving from point A to C, you will cover more, like you will consume, more quantity of petrol than when you are moving from point A to B. Because the distance between AC is more than the distance between what? AB. For instance, if AC is 20 kilometers, let's assume as distance, and then let's say that AB is 10 kilometers. Then, if you spend or if you consume, let us say 50 liters of petrol traveling from A to C, you are going to consume less than 50 liters if you travel from A to B. And if you look at this, the distance from A to C is twice that of A to B, which means that of A to B is half the distance of A to C. Therefore, if you consume 50 liters of petrol traveling from A to C, you are going to consume half of that 50 liters traveling from A to B, which means that we are looking forward to maybe the car consuming 25 liters if you are moving from point A to B. So we can conclude that distance traveled and quantity of petrol consumed during the journey, they are directly proportional. The longer the distance, the more quantity of petrol you expect to consume. And of course, the shorter the distance, the lesser the amount of petrol you will consume. What about linking distance to time? Distance to time, these two quantities are directly proportional. Are you following, right? It's a good example of direct variation in real life. When you are traveling a longer distance, it will take you more time to cover that distance than when you are traveling a shorter distance. If you are traveling a shorter distance, the time taken will also be what? Small. So you see, the longer the distance, the higher the time. And then the smaller the distance, the smaller the time. So you see that the same thing happens to these two quantities. Hence, it's a good example of direct variation in real life. You can think of other examples, are you getting? And of course, use the comment box. Drop some other real life examples of direct variation. Remember the idea. What happens to one of the quantities is expected to be what happens to the second quantity. If this is increasing, the other will also be what? Increasing. If this is decreasing, the second will be expected to what? Decrease. I hope you understand this idea of variation, direct variation. I do believe that if you have any question, please make use of the comment box, and of course, I'll be right there to give attention to that question. Remember, you can become a channel member. Alright, to do so, kindly click the join button just below this video lesson. Alright, once you click on the join button, the GMAT 41's packages for channel members will appear. Select whichever is convenient for you. Support GMAT 41 and become a channel member. This will give you further benefit as you follow through with our guidance here at GMAT 41. Alright, you can also help to prioritize your comment. So once you comment, it appears, and of course, I will be there to just answer your question and more. Let us move on to see how we establish direct variation mathematically. I am going to consider x and y as two quantities that are directly proportional. So I would say that let x vary directly as y. Let x vary directly as what? Y. That statement that x varies as y, whether I use the word directly or not, if I say that x varies as y without identifying the type of variation, it is taken to be direct variation. Don't forget that. If it is inverse, if it is joint, are you following, right? if it is partial, the word, that type of variation will be mentioned in the question. But if it is direct variation, it depends on your examiner whether to tell you that this is directly proportional or this varies directly as the other. The examiner might decide not to mention that it is directly proportional, okay? So just saying that x varies as y, that variation is taken as direct variation. Remember this point, okay? We can establish that mathematically. Are you following? Follow along as I do that. X varies directly as y is written in this way. X then varies. This sign is sign of proportionality, a sign of variation. It is used whether for direct or inverse variation. Are you getting? So saying that x varies directly as y is going to be written as x, then this sign of variation, then I'm going to put y. So you can see that they are written straight on. Are you getting me right? Yeah. X varies directly as y. Then we are going to transform these into a mathematical equation. How do we achieve this? In mathematics, you can't solve anything with this sign of variation. So it has to be removed. Are you getting me right? But you didn't just wake up and then you remove the sign of variation like that. There is something that you need to do that will help you to remove that sign of variation. And what do? As you are removing this proportionality sign, this variation sign, you are going to introduce equal to and a constant. I'm going to use k as the constant of variation here. So we're going to have that x is equal to, then you bring that constant. I'm using k. I'm going to multiply that k by the second quantity, y. Now we shall progress in working on this further. You'll see that x is equal to ky, as simple as this. If you multiply k by y, you'll get ky. So this is an equation that, of course, connects x, y, and k. That k is constant of proportionality. And that constant, as the name goes, it doesn't change. When something is a constant, it remains the same. Are you following, right? So we have this. In general, when a problem is given to you, your examiner sometimes requires that you get your k and then the relationship between x and y, or the equation connecting x and y, or the formula connecting x and y, the variables. In that case, you are going to find the value of k. And once you get the value of k, you fix it into this equation. Are you following? Right? Let's assume that k is half, for example. Then x is going to be equal to 1 over 2, which is half, times y, which is the same as x equal to y over 2. That becomes the formula, the relationship, the equation connecting the variables x and y. Does that make sense? Alright, don't worry, we're going to say that when we pick questions. But at this point, there's something I want to do here, okay? Very important. Yeah, very important. Why? Because of your physics, because of your chemistry, okay? And so we are going to establish something very important. Are you following? I'm going to make k subject of the formula. Remember I said that k is a constant, it does not change. K is constant of proportionality or variation. If I want k to stand alone as subject of formula, you would have to apply a principle of simple equation here. If I want this k to stand alone, I would have to remove this y. To remove this y, I need to divide both sides by y, which is multiplying the unknown, what I'm looking for, what I want to make subject of the formula. Why am I going to divide both sides by y? Because between k and y, the mathematical sign is times. So to remove this y from there, you do the opposite of times, which is divide. So if you divide this left-hand side by y, we are going to have x over y, and that's going to be equal to divide this ky by y, you'll be left with k. Take note of this equation. Now, why did I establish this? I'm going to tell you quickly. If x over y is equal to constant, what it tells you is that x over y does not change. So x over y here at GMAT 41 remains x over y. X over y, wherever you are, remains x over y. It doesn't change. So this is what happens. If I take this point as point 1, which I am going to call initial point, and then take where you are, taking this lesson right away, as point 2, I'm going to refer to that point as final point. So, x over y at this point will be x1 over y1, initial, equal to, remember x over y does not change. So it's going to be equal to x2 over y2 where you are. Since x over y is equal to constant. So wherever this x over y is, it will remain x over y, but you need to indicate the point where that x over y is. Therefore, I'm going to establish using subscript 1 and subscript 2 as initial and final point. I will have x sub 1 over y sub 1 equal to, remember it doesn't change because it's equal to a constant. So it's still going to be x over y, but this time around sub 2 over y subscript 2. So you want to take note of this equation. Let's call it equation 2. The reason I established this equation is really not because of this mathematics topic in variation we are learning now. I had to establish this in order to take you a bit ahead in some other topics that you are going to meet, especially in physics and chemistry, on how certain formulas are being established from certain laws. For example, you can think about Charles' law. Charles' law that relates volume and temperature in chemistry under gas law. It tells us that volume is directly proportional to what? The gas temperature. So we can use this to generate that formula. And if you agree with me, in Charles' law, the formula used for calculation is V1 over T1 equal to V2 over T2. What derived that formula is this direct variation. I want to believe that you understand how I obtained this equation 2. Please make sure you take this point down. Are you following? So that whenever we meet it in other aspects of sciences, you will understand what we are doing there. I want to also remind you of something in physics. Alright, Hooke's law of elasticity. Hooke's law of elasticity tells us that extension is directly proportional to the applied force. Extension is directly proportional to the applied force. So that formula can be generated, can be established, and of course that is how the formula was obtained, that F is equal to KE, using this knowledge of direct variation. Once again, dear friends, please do not play with this topic. It's very, very important in several aspects of your scientific study and hence understanding. Alright, we are going to look at how to apply this concept of direct variation to solving problems now. So we'll take our first question, and I will be glad to come up with a question where we are going to relate something about Charles' law, like I said. Now we've got our first question here. The volume of a gas varies as the gas temperature. When the volume was 50 cubic cm, the temperature was 25 Kelvin. Find the volume if the temperature is doubled. So you see, this is a direct variation question. There is no type of variation mentioned here. We're just told that the volume of the gas varies as the temperature of the gas. So we take it to be direct variation since no particular type of variation was mentioned. Permit me to use V for volume and T for temperature. These are the two gas quantities that the question here is focused on. Are you following, right? So we have that the volume V varies directly as the temperature T. This is the variation statement. V varies as T. Is that okay? Now with this, you know that we are going to remove this sign of proportionality. And like I explained here, you introduce equal to and a constant of proportionality. I'm going to use K. So this is going to be equal to K times T, which is KT. So you want to take note of this. With this information, we can now obtain the value of K. Obtain the value of K first, then use that information to now find what the examiner actually asked you to get here. From this question, we are given first conditions. Are you getting me right? We have when the volume was 50 cubic cm, the temperature of that gas was 25. So I'm going to write. So with this information, we are going to obtain our K. So I'm going to write that K is equal to, I do not know, question mark. So I'm going to substitute it into this equation. Are you following? Let me call this equation 1. I'm going to substitute it into it. The implication is that in place of V, you fix 50 cubic cm, and that's going to be equal to K times 25, because T is 25. This is going to be 50 equal to 25K. And if I have 50 equal to 25K, I can actually get the value of K by dividing both sides by the coefficient of K, which is 25. If I divide it by 25, I'll be left with K. Therefore, K is going to be equal to 50 divided by 25, which is equal to what? 2. And now I have obtained the value of the constant of proportionality. Therefore, the relation, the equation connecting the two variables V and T will be V equal to, in place of K, I'm going to fix 2 and then multiply it by the temperature T. You want to take note of this. whatever we do, we are going to come back to this equation. Let me identify it as equation 2, and then I'll asterisk it. You know, this equation 2 is called the formula connecting the two variables v and t, or the equation connecting the two variables v and t, or the relationship between the variables v and t. Any other thing your examiner asks you to find for this particular question, all you just have to do is to come back to this relationship between v and t, and then fix your known value, calculate the unknown. For example, in this second part of the question, we are required to find the volume if the temperature is what? Doubled. If the temperature is doubled. So you're going to write when t is doubled. So it's going to be when t is equal to 2 times the original t. You know, the original t is 25. So if you double it, it's going to be 2 times 25, which is going to give us 50 Kelvin. Now, we are asked to find the volume. So I'm going to write that V is equal to unknown. But we know this relationship connecting V and T. So you're going to recall. So all we have to do is to now substitute into this formula and then solve for the unknown. We don't know V. So I'm going to still maintain V equal to 2 times T. The value of T is 50. So that the volume under this condition will be 100 cubic cm. That is the value of the volume of the gas if the temperature of the gas under this condition is to be what? Doubled. And of course, we are done solving this question. You can see how simple handling this problem is. We could have decided to use this approach. Are you following, right? To still get the same answer directly if we had wanted. You know, as a matter of fact, you know, this is Charles' law problem in chemistry under gas law. We could have used V1 over T1 equal to V2 over T2 to solve. In that case, I will not need to calculate K. I wouldn't need to do that. Are you following, right? It will not be necessary. All I have to do is establish this formula in this format. You know, with this, if I make K subject to the formula, I will get V over T equal to K, giving us V1 over T1 equal to V2 over T2. If I do V1 over T1 equal to V2 over T2, I have the value of V1 and T1 already. I'll just substitute it into that value, into that formula, that is 50 over 25. And that is going to be equal to V2, I don't know. I'm going to write V2 all over T2 is double of T1. 2 times 25 will give you 50. So you're going to have something like 50 over 25 equal to V2 over 50. If you solve this for V2, you are going to get 100 cubic cm as this. I hope you enjoyed this calculation about variation, direct variation to that. So that's how simple we handle this. Let's take, this time around is going to be a Jamb question. Is that okay? Alright, now the second question we have here on the board. If x varies directly as the square root of y, take note of that, and x equals 81 when y equals 9, find x when y equals to one whole number 7 over 9. Let's move on to deal with this. How do you solve this question? Is a simple one. You say, if I like, I can just go straight and do, you know, x1 over square root of y1 equal to x2 over square root of y2. As a matter of fact, in examination hall under CBT cases, okay, objective, that is the best thing to do. You can use x1 over square root of y1 equal to x2 over square root of y2. Then substitute this. For x1 is 81, so you're going to have 81 over square root of 9 equal to x2 you don't know over square root of y2, which is one whole number 7 over 9. Convert this to improper fraction and then you solve that equation. That's the fastest thing to do, but I wouldn't go in that direction. Are you getting me right? Because my aim is for you to know how to solve this. Get the whole idea mathematically, no matter the level you are. You might still be in school learning this. Are you following, right? And of course, your examiner in theory case may expect you to present the work step by step. So for that reason, let's handle this, you know, in the right way per se. So we are going to have that x varies directly as the square root of y. That is going to be written as this. Don't forget square root of y. The implication, removing variation sign, is going to be x equal to k times square root of y. And then with this, we are giving conditions. You know, the first condition, x equal to 81 when we have y equal to 9. Will imply that 81, you're going to fix it for x, look at it, equal to k, you don't know, then times square root of y. y there is 9, and this is going to give us 81 equal to square root of 9 is 3. 3 times k will give us 3k. And what does that mean? Solving for k, the value of k is going to be 81 divided by 3, which of course is going to give us 27. So the relationship connecting the two variables x and y is going to be x equal to, our k is 27, so in place of k we're going to fix 27, and then I shall multiply it by square root of y. Is that okay? And so for the next part of the question, where we are actually required to find x, we shall use that relationship, that formula, that equation connecting x and y. We are asked to find x when y is equal to one whole number 7 over 9. So I'm going to write, when x is unknown, the value of y is one whole number 7 over 9. Please, you want to remember, whenever you're given mixed fraction, you're solving something, convert that mixed fraction to improper fraction. How do you achieve that? You do denominator times whole number, whatever you get, add it to the numerator and divide everything by the denominator. So we go, 9 times 1 will give us 9, add it to 7, you get 16, all over 9. So the value of y is actually 16 over 9. So the implication of this, it implies that using this relationship, x is what we are looking for, we don't know. It's going to be equal to 27, then times square root of y, and y is 16 over 9. Take note of this, square root can distribute over division and multiplication. What do I mean by this statement? I have square root of 16 over 9. The square root is covering that 16 and 9. So since it is division, you can split, have square root of 16 over square root of 9. Are you following, right? Although I'm going to show it, but subsequently, if we meet something like that, I wouldn't show it. And you don't need to show it, it's not necessary, okay? I've already explained the implication of that. So this is going to be square root of 9, which we are going to get that x is equal to 27. And then with this, you know, we can multiply 27 by 4 and then divide by 3. But there is something about board mass you want to remember. Board mass. You do division before multiplication. As long as you can divide, please, divide before you multiply. I always advise for that. Reason, when you divide first, your numbers reduce. Then multiplying will be easy. But when you multiply first, you know, your number will increase. Dividing might give you certain stress. 3 can divide 3, you get 1. 3 can go into 27, you get 9. And then 9 times 4 would give us 36. Therefore, the value of x when y is 16 over 9 or 1 over 7 over 9 is equal to 36. And of course, this is the answer to this question. The correct option is option D. Please make sure you take your multiplication seriously, very important, irrespective of your level of education. Whether you are in university, whether you are in senior secondary school class, whether you are in basic level of learning, don't joke with multiplication. To help you a lot to be able to handle these things faster. Are you following, right? At least from 2 times table to 9 times table. You need to know that. Alright guys, so this is much about direct variation. With what you've learned from this video lesson, you can deal with any other form of direct variation anytime, any day. Make sure you watch this video lesson again and again. Are you following? If you have any question, make use of the comment box and I'll be there to respond. You can become channel member, like I said, in order to prioritize your comment, your questions, so that it can be attended to fast. Please, we appreciate you supporting GMAT 41 by becoming channel members. Share this video to your friends, to other scholars, invite them to join us. Remember, we also prepare you for your professional examination, for Jamb and for Waec. Alright? Stay with us so that you can learn very well and get coached for these examinations. I'll be seeing you in our next video lesson where in mathematics I'll be treating inverse variation. Until then, from GMAT 41 here, remember to take your studies seriously.